All right. Good morning, everybody. Today is Tuesday, August 29th, 2017. And this is Before the First Cup with Jules here on UCY.tv. Happy Tuesday, everyone. It is an overcast 60 degrees, and it looks like it's going to pour here any minute here in upstate New York. And if you look at the map, there's some big blob coming up the coast. And I thought I heard something yesterday about it being a tropical storm. Not too sure about that. So where do we leave off on Thursday? We titled the show Guest Drew Lamb. We discussed the Eclipse, Hanford, AI, mind control, and Civil War II. It's pretty interesting. Talking to Drew is always a treat. I haven't talked to him in about a year, and we tend to think about some of the same things. He was up in Oregon for the Eclipse. He said it got kind of strange up there. I only noticed really weird shadows here. But Hanford as well, he's got a page. If anybody is on Facebook, it is facebook.com/Hanford Facts. And he came into possession of a whole bunch of documentation from a friend's dad who passed away, who had formerly worked for the CIA, I guess, and had done a lot of different research into what was going on at Hanford, and he had all kinds of documents. So Drew has been working on putting those online if anyone is interested. And I'm sure that that page is probably publicly accessible as well, even if you don't have Facebook. So where do we leave off on Wednesday, which was the day before? We titled the show Killer Robots, Urban Warfare UAVs, Self-Healing Skin Jobs, and AI Safety. I think we're going to get back to AI today. I had gone through my news feeds yesterday and came upon 4 or 5 good stories that all kind of interlocked with each other that I thought would make a good show for today. So we ended that show on Wednesday, which was 6 days ago, about looking at Elon Musk and how he again is coming out calling to the UN for a ban on killer robots. And there are hundreds of other AI scientists and experts in the industry even that have come out to support him, saying that we should do it now before it is too late. We have the military-industrial complex that is working overtime on trying to create intelligent robots. We looked at a story, and I don't know if it was Wednesday or if it was Tuesday, about IBM creating their True North chip. Yeah, here it is, the Air Force Research Lab, which is another one of those mad science laboratories like DARPA that does crazy things. IBM develops brain-like supercomputer for U.S. Air Force Research Lab. And remember, this research is going on globally in a new technology war. This is where the warfare is really happening. It's not bombs anymore, nuclear, schmuclear. Even Elon Musk had said that this really is the next nuclear danger that we have, is this AI war that's going on and creating an intelligence that does not need human intervention to make decisions. And they're getting pretty far ahead. You know, like I've said many times before, and Musk has echoed this, it's happening much, much faster than we think because of the law of exponential returns. And as technology begets technology, and we've already read stories about AI creating its own AI, or AI creating its own language that has to then get shut down because it's becoming a little dangerous. We read about an AI, Elon Musk's open, whatever it was, his open forum where they're doing all the testing, trying to make sure that AI stays good. They had an AI play a strategy, a military strategy game. I don't remember what it was called, something too. And it beat the human. That was cause for alarm because military strategy, of course, is where we think we have the leg up. But if these machines get smarter than us and then they decide that we're no good, well, we're going to have a bit of a problem. So anyway, back to IBM. This True North chip, bigger, actually smaller, faster, smarter. That is the name of the game. And whoever can do that and put more intelligence and more instruction in the head of a pin is going to win this game. Technology company IBM, the same company that created Watson, is developing a new supercomputer powered by 64 True North chips for use by the Air Force Research Laboratory as part of a collaboration announced in June of 2017. This new brain-like supercomputer will be used for analytics involving pattern and object recognition, as well as sensory processing. Now, let's look at what that definition means. And we looked at IQ before, and one of the big telltale signs of IQ is to be able to recognize patterns and connect dots. Another thing that we've had are robot googly eyes, and we're going to talk about those later in regards to the Internet of Things, this whole connecting the world to this new intelligent, ubiquitous network that will exist everywhere and be connected via the likes of 5G and millimeter wave technology on a global scale. And remember, there is a global timeline for all of this. This is being rolled out as the net that falls over all of us that we will never be able to get out of. And the third thing they said that they want to use this new supercomputer for is for sensory processing. And remember, what is making these computers so intelligent and better than us is giving them their five senses. We are giving them a time and a place in the universe to be able to mark and then relate themselves to the outside world. And this is dangerous. This is where we have to start wondering where being cognizant comes in. Once you are aware of your surroundings and your place in the universe and the self versus the outside, does that constitute some sort of consciousness? And then if they could start building ethics into these things, and that's one thing they haven't quite figured out how to do yet. No Isaac Asimov rules, but soon if they have their way, don't worry, we have Google working on a team that is going to be, and I think DARPA as well, it's going to be figuring out how to build a kill switch and how to make these things ethical. So don't worry about it, people. But they're going to let them look at cat pictures, millions of them, as a matter of fact, on YouTube, to be able to distinguish whether it's a cat or a dog by using the robot googly eyes. And not only that, but your face as well, 230-point facial recognition, and being able to determine not only whether or not you're thinking unpure thoughts just by the expression, the micro expressions on your face, but also by the sound of your voice. They'll be able to analyze your voice and tell whether or not you are mentally ill or even physically ill on a spectrum and diagnose you at a distance. Pretty frightening. And if we get there, I have some nutty stories about that as well coming. So this true north neurosynaptic system, and remember, Dr. Watson is already working on healthcare. This true north neurosynaptic system has been designed to imitate human neurons and can convert ding-a-ling audio, video, and other forms of data received by sensors into symbols, which makes it their own language, which the computer can then process and share amongst itself without us even knowing what they're talking about. And it is capable of performing advanced computations using less energy than conventional chips. Remember, Facebook pulled a super genius computer scientist out of Stanford or one of those California universities out of retirement to help them come build a new computer data center that was going to make their chips way more powerful, save them bazillions of dollars so they didn't have to rebuild it, and make these more intelligent in a smaller footprint. Guys, this is where the danger comes in, and everything's being fed to the cloud. And it's going to be Skynet. Skynet will be true. Skynet will live. Google has already let the stuff loose on the internet as part of their search engine. Soon to get bigger and bigger. Microsoft is already in the game as well. Guys, these rich tech companies and these rich tech investors are all going to own the network that enslaves us. They've already enslaves us, but even more so in the future. And they'll be able to kill us in the future as well, determine that you are a difficulty, you are an insurgent, you are not healthy for the white-walled society that they are planning, where all of us is bag tagged and scanned, and healthy because it's cost-effective. You're not going to be one of those people. Neither am I, unfortunately. And they're already discovering that as I'm being bagged and tagged on a daily basis back in the medical industrial complex that I have so shunned for so long. So anyway, back to this IBM supercomputer. It is capable of performing advanced computations using less energy than conventional chips. And I wonder where that DARPA one is. Here we go. There's a story that came out about DARPA yesterday and some chips. The Air Force Research Laboratory's principal electronic engineer, King Wu, said, and that's King Q-I-N-G, Wu, said, this is about building more intelligent machines that will work with humans to make human operators and analysts more effective and efficient when dealing with data. Yeah, of course, it's all about helping humans. So they keep telling us, except you're training the machine. Every little bit of input that you put into it right now is teaching the machine more about humans, more about the world and how it works, more about our genetics and how to flip switches on and off, how to make things better, how to determine whether or not you are, quote, good or you are, quote, bad, based upon lots of different big data about you that they've been collecting for a very long time. We read a story about artificial intelligence and the spies last week, maybe Tuesday or so. And one of the things that it looked at is how they were utilizing all this data to create a dossier on you. And I've talked about that many times before. Your dossier is going to give them a red light or green light eventually on a dashboard and tell them whether or not you should be considered a danger. This was interesting. I closed all of my tabs and I reopened them before the show because my machine was pegging for memory. And it appears now, not just with these few tabs I open up just for today's show, I'm already at 92% physical memory on this machine, which is my newest of the three, one of which died last week while I was not here, just never powered up again. So hopefully I can scroll. I don't know what's going on now. Damn it. Well, hold on. I'm going to open up my source of links. So if I have to, I can open these all again. And I got to log in. And I'll have to do the elephant song in a second. Hold on. Old password. Do 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 do. Oh, my browser just disappeared now, and I went to 98%. Do 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 do. I think it is Google Chrome that goes out of its way to break everything because it keeps trying to force me to make an update. And I keep saying, no, thank you. I don't need an update. And it keeps saying, okay, then screw you, Jewel, because you do need an update. And if you don't get one, what we're going to do is just crunch your browser every time you decide that you're going to use it to do a show. Make it suck all your system memory. And that'll be the end of you. All right, we're going to try this again. Oh, come on. See, guys, I'm going to tell you, this is exactly why my blood pressure doesn't do well when I do the show. It is hazardous to my health. Oh, and I think it's on purpose. You know, something else I was reading about blood pressure the other day and clotting mechanisms and that. If you sit in a chair, this was pretty surprising to me, especially since I've done it for 30 years, but if you sit in a chair and you have your legs hanging off that chair, that is not good for the circulation in your legs. And then if you put your legs, because you feel like your blood is pooling in your feet, if you put those legs on a footstool and they are at a 90-degree angle to your body, that's even worse for the return of blood back through your heart and worse for your physical body. Oh, look at this one isn't responding either. Two computers at the very same time trying to get into the same application, and it is not working. Guys, I don't have backup number 3, so this might turn into a headache for me. All right, so I can read whatever is left on this page that doesn't scroll now. Oh, this is unbelievable. This brain-like supercomputer will be used for analytics involving pattern object recognition and sensory processing, and it can use less energy. Oh, damn. It can use less energy than conventional chips. The Air Force Research Laboratory's principal electronic engineer says it's about building more intelligent machines that work with humans to make human operators and analysts more effective and efficient when analyzing data. And I guess we're going to have to end here because this whole machine is at a standstill. But hold on. Hold the phone because we're going to open something else. They will not stop me. All right. So I think we read this story once before, but it kind of struck me as all this medical stuff is coming out. AI is now able to predict when you are going to die. Only if you are a patient with radiological test scans. So get into the system. Electronic medical health records. Doctors are the only ones who can tell or estimate how long patients are going to live. Well, not anymore. It's because artificial intelligence has become so smart that it can also do the same job. Now remember, robots are going to come take all your jobs, and not just the blue-collar jobs, but also the white-collar jobs. Including those of a doctor, a neurologist, an oncologist, a genetic engineer. That's because artificial intelligence has become so smart it can do the same job. Researchers at the University of Adelaide, and that I believe is in Australia, were able to develop a system which was able to predict patient lifespans. And after looking at radiological test scans, I'm assuming it's going to be, I don't know, X-rays or CT. The AI system analyzed and found patterns to say which among 48 sample patients would die within the next 5 years. And it was able to predict death with a 69% accuracy, according to the researchers, which is equivalent to the rate of a trained human oncologist. So this must be for cancer patients. And now the team, I wonder if it is Watson, and now the team behind this technology claims to have an updated version that has surpassed this rate. Lyle Palmer, a professor of genetic epidemiology in the university, and one of the researchers, revealed that the inspiration behind the AI system is to model how the human brain learns through deep learning. And although the fundamental ideas behind deep learning are not new, dramatic improvements in computing capacity and access to large data sets have enabled a widespread use of deep learning approaches in the industry and academia over the last 5 years, and the use at a very early stage. Remember, this is just the beginning. And as these things are able to decode whether or not you're going to die and where all of your weak points are and your chinks in your armor, they'll be able to come up with, what do they call it, precision ways to take us out on an individual level, one by one. Blink, blink. Especially if you are a troubled child. Radiological images have been an untapped resource. Ding, for precision medicine, he said. Exactly, just like I said. And there is so much potential and valuable information in hundreds of thousands of images. I told you my CD had like 41,000 images on it, taken by hospitals for routine clinical purposes, and these could be used for diagnostic and prognostic purposes. Other than predicting the death of patients, the AI system, when perfected, could be useful in forecasting the onset of chronic diseases such as diabetes, heart disease, and cancer, even before symptoms are evident. Early diagnostic of chronic diseases is one of the holy grails of modern biomedicine, says Palmer. And however, the technology is still so young. He wants to know if I want to change my color scheme to improve my performance. No, ask me again if it starts to perform slowly. This computer is dying quickly. However, the technology is still so young that doctors cannot do anything with the information that AI produces to help patients, since current models are only capable of predicting 5-year mortality in a subset of patients being imaged with thoracic CT scans, like I said, in a hospital setting. It already overflows with potential, though, as present. It predicts death with around 80% accuracy, and this is far better than a human doctor could do. So there you go, out of ResearchGate. Here's something else about prediction and finding you. You don't even own your own face. Even more sophisticated technology will allow the likes of Facebook to not only locate you, but to profit from it as well. Have you been tagged in a Facebook photo lately? No, I have not. Think this is a harmless or fun act? Well, in reality, and this is what I've always said, you are feeding one of the scariest beasts in the technological forest. You are accelerating the development of a massive face recognition engine that has the potential to recognize every man, woman, and child on this planet. Not only in airports or on city sidewalks, and I had a story about airports, but also in hospitals. We would be hurtling toward a future where anonymity, as we know it, and I've always been a biggie for anonymity, not because you're doing anything wrong, but because it is nobody's business what you are doing, is no longer possible. While facial recognition was invented in the early 1990s by a handful of pioneers, it is the hundreds of millions of social media users today who are unconsciously perfecting the technology with the power to end privacy, not just online, but in the physical world as well. This technology is now growing with a speed and sophistication few imaged possible. We, the people who own our own faces, have lost control over how they are used. But we do not have to surrender. We can and must pass laws. Yeah, of course we do. To guide the industry and guard against the abuse of facial recognition. And we must do it soon. Because as someone who is part of a handful of pioneers that invented facial recognition, I feel that it is my responsibility. I'm telling you guys, this is what's happening to a lot of people from my years of working in this industry. We are looking at how we created a monster that is being used in not ways that we had anticipated. I feel it is my responsibility, and then as the author of the story, who would be, I don't know, does it say it? Joseph J. Ettick, the New York Daily News, to warn against the creepy side that could emerge. And there is nothing new about the basic technology here. Computers have been able to automatically detect faces in photographs and from videos and identify who they are for some time. But if you saw any of the James Bond films nearly 2 decades before the technology was actually invented and over the last 15 years, the technology, propelled by legitimate security needs in the aftermath of 9/11, wink, tingling, has evolved dramatically from those fictional depictions to become very real. And that's lots of pre-programming that has been involved in the recent past for absolutely certain. But even more recently, it received major boosts from the mainstream IT industry and has become familiar to the consumer through applications from Facebook, Google, Apple, as well as a myriad of other mobile and payment and banking applications. And it is even rumored on the next iPhone that will rely on facial recognition as a primary method for controlling access. Many of these applications are perfectly welcome, at least in his world, especially those that help defeat ID theft and other crimes. But today, along with technologies that measure patterns of fingerprints and iris of the eyes, facial recognition represents a cornerstone in the ensemble of modern biometrics, which aim to establish individual identity based on uniqueness of measurable physical characteristics outside of the human body, such as the geometry of the human face. Programs that use biometrics to uniquely identify individuals to combat identity fraud, identify criminals from surveillance photos, secure mobile transactions, and expedite border crossings or dispensing social services, like some of those biometric IDs that are being used overseas. And I thought we found out there were 130 some countries now who are tinkering with that. We're now very common worldwide, and their scope continues to grow. For example, the NYPD has one of the world's most advanced facial recognition programs, ding-a-ling, for forensic investigation, only matched in capacity by the so-called next-generation programs of places such as the FBI. But when used for large-scale identification, and I lost my place. But when used for large-scale identification, as opposed to simple authentication that you are who you say you are, facial recognition raises some serious concerns. And unlike DNA analysis, fingerprints, and other biometrics, it can only be surreptitiously performed from a distance without a subject's cooperation or consent. Ding-a-ling. And if it works for ordinary photographs without the need for special scanners or cameras, that's what makes it ubiquitous. And these concerns are not new. They immediately came up as the technology began to be commercialized back in the 90s with the context of law enforcement applications. But today we are in a different era, so look out. And the problem is much larger. The simplistic self-regulations that worked back then will not work now, and the technology has escaped the orbit of control. Danger, Will Robinson. And what changed everything is about the abundance of facial photographs on social media. Facial recognition systems are as good as their reference database of known faces against which they perform recognition. And this gallery, and this is the gallery of faces, and without it, the system would be said to be face blind. So delete them all and blow up the existing cloud that's out there. I don't even know if a big EMP would work on that, because the cloud is ubiquitous. It is spread across multiple data centers across the planet, and all using some sort of recovery technology, whether it's just tiny slices of each pie at each data center or underground facilities where it's all backed up to. There's no erasing anything that you've put out into the interwebs, including texting, including any type of electronic media. It's going to be out there forever. So what changed everything is the abundance of facial photographs on social media. Facial recognition systems are as good as their reference data sheets of known faces against which they perform recognition. In this gallery of faces, without it, the system was said to be blind. Back when facial recognition was invented, building a face gallery was a big challenge. Most of the photographs had to be scanned one by one and added to the database manually. This meant that galleries were limited in size, and the impact of those early systems was limited. For example, for law enforcement applications, all we had to make sure is that the gallery contained faces that were legitimate targets for law enforcement, such as individuals with warrants or felony convictions, or who were a part of an active investigation. But for the other 99% of the populace, facial recognition would be blind. Anonymity and privacy would still be enjoyed by the clear majority. And at the time when we invented facial recognitions, we did not imagine that the day would come when this clear majority would voluntarily be feeding images of their faces into massive databases such as Facebook. Ding, maybe that was the plan all the time. How ingenious is this web they weave? Anonymity does not exist now. Social media users today get the credit for having built the world's largest and highest quality face gallery, orders of magnitude larger than those maintained by the FBI, and it is crowdsourcing at its best. And then, of course, you feed in all of your daily feelings and smiley faces and whatever to tell them what type of person you are. You share your angst on a daily basis, and I don't do that. I do sciencey mental stuff on my page. And to tell you the truth, there has never been a time, I don't think, that I have uploaded a full face to the Facebook database without some sort of artistic twist to it that kind of makes it hard to see the points of cheeks and things. I've always been aware of that. Social media users today get credit. And in addition to serving as reference galleries, the massive abundance of face images allows the deployment of a class of intelligent algorithms called deep learning. And these powerful data processing methods also automatically learn to classify image content through examples. Software developers do not have to code the classifiers needed to tell a computer what a face is on an image and who it belongs to, the eyes, mouth, nose, and other feature detectors. All they have to do is show computers a large number of examples of photos of faces, and the deep learning takes care of the rest The result is a software engine that learns what makes a face and not a car, not an animal, and that can distinguish between billions of faces in countless settings and at countless different angles from one another. This class of facial recognition engine has already surpassed the accuracy of old systems and has even exceeded human performance, as demonstrated by the face research and development team. And as users upload more and more images, for example, to Facebook, each image is processed automatically to detect faces, and detect each face is converted to a specialized mathematical code that is then called a FacePrint. These highly compact codes, which don't even take that much computer memory to store, capture the uniqueness of your face, as in principle, no two face prints are alike except for identical twins. And today it is estimated that Facebook maintains a database of over 1 billion face prints. Thousands of processors are involved, and this is what I said, distributed over thousands of servers in multiple computing farms all around the world to just deal with face prints. Facebook justifies the massive undertaking by the need to support a popular feature, and while this is all well and good, it is neat to see photos tagged automatically. It is sidestepping what should be serious concerns for users. By default, everyone is in opt-in mode, submitting to facial recognition, and one would have to be consciously taking an action to opt out, which is an effort that requires some sophistication. All right, guys, sorry about that. That required a full reboot that wouldn't happen. I don't know, my screen went black, everything went dead, and then the machine would not reboot, so I had to do a full reboot and sit here and hold the button down. So I was reading for a bit, and I guess it wasn't that important. We were talking about Facebook and federal law and all the tech giants owning your face. And as one of the inventors of facial recognition in the early 1990s, Atik is a chairman of the Identity Council and the ID for Africa, which are movements to give legal identity for all around the world by 2030. So I don't know what that means. So is he all for this or not? And as someone who witnessed the birth of facial recognition and accompanied it through its formative years, his dream is to see it mature, add safety, security, and convenience to the consumer without taking away their control of their own privacy or their personal data. So, But check this out. The rise of the ubiquitous computer vision in the Internet of Things. We've talked about robot googly eyes before, and the Internet of Things in surveillance, and how surveillance is becoming ubiquitous. Of course, facial recognition is a biggie. The evolution of computer vision. So this is out of IoT for All by Frank Lee, August 27th, 2017. You can easily find computer vision technology in everyday products, from game consoles that can recognize your gestures to cell phone cameras that can automatically set their focus on people, and it is impacting many areas of our lives. But in fact, computer vision has had a long history in commercial and governmental use. Optical sensors that sense light waves in various spectrum ranges are deployed in many applications, like quality assurance in manufacturing, remote sensing for environmental management, or high-resolution cameras that collect intelligence over battlefields, or facial recognition software that detect you from your light post in town. Some of these sensors are stationary, where others are attached to moving objects such as satellites, drones, and vehicles. And in the past, many of these computer vision applications were limited to some closed platforms, but when it combined with IP connectivity technology, they create a new set of applications that were never possible before. Computer vision, coupled with IP connectivity, advanced data analytics, and artificial intelligence, will be catalysts for each other, giving rise to revolutionary leaps in the Internet of Things innovations and applications. Now, please do me a favor and tell me if you guys can hear me. Yay! I see it. Thank you. So environment designed for vision. Sight or vision is the most developed of the 5 human senses. Ding, ding. That's what I said. Giving these computers our 5 senses is what is going to doom us. We use it in daily lives to recognize our friends, detect obstacles in our path, and to complete tasks and to learn new things. We design our physical surroundings for our sense of vision, and there are street signs and street signals to help us get from one place to another. Stores have signs to help us locate them, and computers and television screens display information and entertainment that we consume. So, given the importance of sight, it is not a big leap to extend it to computers and automation. Computer vision starts with the technology that captures and stores an image or a set of images and then transforms those images into information that can be further acted upon. It is comprised of several technologies that work together. Computer vision engineering is an interdisciplinary field crossing multiple functions and system enterprises and a number of technologies. For example, Microsoft Kinect uses 3D computer graphic algorithms to enable computer vision to analyze and understand three-dimensional scenes. It allows game developers to merge real-time full-body motion capture with artificial 3D environments. Besides gaming, this opens new possibilities in areas like robotics, virtual reality, and augmented reality applications. Sensory technology advancements are also happening rapidly at levels beyond conventional cameras. Some recent examples include infrared sensors and lasers. We've talked a lot about lasers. Combine the same depth and distance, which are about one of the most critical enablers of self-driving cars and 3D mapping applications. Also, non-intrusive sensors that track vital signs of medical patients, without physical contact. High-frequency cameras that capture subtle movements not perceivable by the human eye to help athletes analyze their gaits or to identify you by your gait or tell if you're lying by your micro-expressions. We've talked about those, as well as ultra-low-powered and low-cost vision sensors that can be deployed anywhere for a very long period of time. We've talked about those also, some of those cameras that can run forever. The surveillance industry is, of course, one of the early adopters of image processing techniques and video analytics. Video analytics, in a special use case of computer vision that focuses on finding patterns out of hours of video footage, the ability to automatically detect and identify predefined patterns, in real-world situations presents a huge market opportunity with hundreds of case uses. The first video analytics tools used handcrafted algorithms that identified specific features in images and videos, and they were accurate in a laboratory setting and simulation environment. However, performance quickly dropped when the input data like lighting conditions and camera views deviated from design assumptions. Researchers and engineers spent many years developing and tuning algorithms or coming up with new ones to deal with different conditions. However, camera and video recorders now use those algorithms, and they are still not robust enough, despite coming incremental progress made over the years. Poor real-world performance limited the usefulness and adoption of technology, but guess what? They've overcome all that now with AI. In recent years, the emergence of deep learning algorithms has reinvigorated computer vision. Deep learning, which mimics the neurons in the human brain, and starting in the early 2010s, computer performance accelerated by graphics processing units or GPUs has grown powerful enough for researchers to realize the capabilities of the complex. Besides partly driven by video sites and prevalent IoT devices, researchers now have diverse libraries of video images and data to train their neural networks. In 2012, the version of the deep neural network, DNN, called convolutional neural network, demonstrated a huge leap in accuracy, and that development drove renewed interest and excitement into the computer vision field of engineering. Now, in applications requiring image classification and facial recognition, deep learning algorithms have exceeded their human counterparts. More importantly, just like humans, these algorithms have the ability to learn and adapt to different conditions. With deep learning, we are entering an era of cognitive technology, and that's how they always referred to IBM Watson, where computer vision and deep learning integrate to address higher-level complex problems once the domain of the human brain only. And we are just scratching the surface of what is possible, so look out. Those systems will continue to improve with faster processors, more advanced machine learning algorithms, and deeper integration to edge devices. Computer vision is set to revolutionize the Internet of Things. And guys, this is where the worry comes in, because they will be able to target you with quite a big accuracy, find you anywhere, be able to bag, tag, and track you, determine what type of person you are, and take you out if need be. And as they give all this data to the machine, let the machine make determinations for itself, we are in grave danger, because the machine one day might decide that you are a danger to itself and others. All right, so let's go on to another story. Since I've had to cobble this show together, the age of AI surveillance is here. This is out of Quartz Magazine, QZ.com. The age of AI surveillance. And we'll see if I can scroll this now. Come on, baby. Just a little bit more. For years, we have been recorded in public on security cameras, police body cams, live streams, and other people's social media posts, and on and on and on. But if there is a camera in our face, there has always been a slight assurance that strangers wouldn't really be able to do anything that affects us with the footage. Well, guess what? The time and effort it would take for someone to trawl through months of security footage to find a specific person or search the internet on the off chance that they'll find you was just unrealistic, but not for robots. Long possible in Hollywood thrillers, and we found out that there's already a system out there, like out of Bourne movies, who can track you across any form of video footage. The tools for identifying who someone is and what they are doing across video and images is taking shape. Companies like Facebook and Beidou in China, they're Google's equivalent in China, and the technology wars are on, have been working on such artificial intelligence-powered technology for years, but the narrowing rate of error and the widening availability of these systems foretell a near future when every video is analyzed to identify people, objects, and the actions inside. AI researchers struggled for years to build algorithms that can look at an image and tell what it depicts, and the complexity of images, with them containing millions of pixels that form unique patterns, was just too complicated for hand-coded algorithms to reliably work. But then in 2012, which was a great year in the coming of Skynet, researchers demonstrated that the technique called deep learning, a system that took and generated ideas of our brain's interconnected neurons and translated those into mathematical functions, worked far better when working with large amounts of images. And if a deep neural network, as the system was called, was given enough examples, it could suss out a shared pattern between images, like the shape and texture in common between cats. Remember, they put Google's AI on cat images on YouTube to teach it. Since then, the systems have grown in complexity and scale, and researchers began making larger networks of neurons, while hardware manufacturers like NVIDIA, and they're the one who took their GPU that used to only be used for video games and turned it on to AI, began building specialty processors to make the networks exponentially faster. The result has been an explosion in what the systems can accomplish. And given a large data set of images or video, these systems can be trained to learn what a person's face looks like and reliably identify it again and again and again. The largest public example of this is Megaface, a project out of the University of Washington, in which the data set contains nearly 5 million images of 672,000 people sourced from Flickr's Creative Commons. And in July, the Megaface team presented the latest scores of algorithms trained on the dataset, and when tested on matching two images of the same person in a separate dataset of 1 million faces, top-ranking teams touched 75% accuracy when given one chance to guess, and more than 90% accuracy when allowed 10 different options. We need to test facial recognition on a planetary scale, they say, to enable practical applications. Testing on larger data sets lets you discover the flaws and successes of recognition algorithms, says Ira Kelmacher-Schlitzman, a UW professor who oversees Megaface. Video, which uses similar techniques to still images but requires higher processing power, also allows AI to understand what is happening over time. Baidu, the Chinese search giant, announced in late August of 2017 that it had won the ActivityNet Challenge, which correctly labeled the actions of humans in 300,000 videos with an 87.6 accuracy. These are actions like chipping wood, cleaning windows, or walking a dog. Facebook has also demonstrated interest in this technology to understand who's in live streams on site and what they are doing In an interview last year, Director of Applied Machine Learning Joaquin Quinucero Candela said that ideally Facebook would understand what is happening in every live video in order to curate a personalized video channel for users, but that isn't why. It was because people committed suicide on live video, and they wanted to make sure that that did not get streamed live again. Whoops. So they needed an AI algorithm to understand what was going on. Let's get back here. The U.S. government has already began using the technology in a limited capacity. Last week, the New York Department of Motor Vehicles, DING, announced that it made more than 4,000 arrests using facial recognition technology instead of scanning police footage and software used to compare new driver license application photos to images already in its database, making it tougher for fraudsters to steal someone's identity. If a state or federal government expand into deploying facial recognition in public, they will already have a database of more than 50% of all American adults from repositories like the DMV. And again, the bigger the data set, the better the AI. And that might not be far off. Axon, a company known as Taser and the largest distributor of police body cameras in the U.S., has recently ramped up ambitions to infuse AI into its products, acquiring 2 AI companies this year. Axon CEO Rick Smith told courts previously that the ideal use case for AI would be the objective generation of incident reports, giving police more time out from behind the desk. So you're going to have an AI not only taking live video camera footage of you when you encounter a police officer, but I'll guarantee you there's already technology out there that we read about where they will edit out the boring parts of your video, and they will also generate incident reports by understanding what is going on in the video automatically without a human. Facial recognition, he noted, is active now, but it isn't active now, but it could be in the future. Motorola and other major body cam suppliers pitches its software on its ability to quickly learn faces, highlighting a scenario where an officer is lost child. All right, guys, thanks for hanging out today. I've been John.